Hi all, I'm Nitish and welcome back to our channel ML for Analytics. In this video, I will be covering our topic that is basics of NumPy array and part 2 of it to be specific. In our previous video or in our article in our blog, we studied about array attributes, slicing of arrays, and array indexing. If you are interested in studying about them, I will be leaving a link for them in our description. Please do check that. And coming back to this video lecture, I will be covering these 5 topics, and the first of one of them is data types in NumPy, then create a copy of array, reshaping arrays, array concatenation, and splitting arrays in multiple parts. So let's begin with data types in NumPy. Just like any other language, Python is no different. Though we would have been thinking like a variable in a Python automatically decides that what type of data type it should have. That is very well true. But what if we want to create a specific data type in an array, or we want it to have specific data type values? Then here comes our data types in NumPy. So this is the list of all those data types, at least most of them, which are supported by NumPy. The first one is Boolean, true or false, unsigned integer of 0 to 25, 0 to 65535, and so on. Similarly, we have the standard int types, varying with the value sizes, and you can choose accordingly whatever you want. For decimal values, we have float, and one more thing to note over here is like float underscore and float 64 represents the same thing. You can use either one of them. It will not create an error for you. And similarly, for complex 128, you can use complex underscore as well. That is the, if we talk about like int 64, float 64, complex 128, they are the max supported values in their fields, and they can also be represented by like int underscore, float underscore, and complex underscore respectively. So all you have to do is just use them only when you are using the max, you want your array to support the maximum range of values. Otherwise, try to use the specific ones because you will be wasting your machine memory. Now let's moving forward to an example. Before everything, let's import the NumPy, and here you can see I'm trying to create a data type of integer 65 or an array having a type of integer 64. So let's run it, and as you can see, I got the values integer type and d type is int 64. Now for float 64, as I said earlier, I can use float underscore as well. These are the values of decimal type, and for the complex, let's run this one as well. As you can see, these are complex values and of type complex 64. Now you would be thinking why I didn't get a data type over here. So let's try to run something else like float 32. Now we are getting this as well over here. So that covers our data types for the array. Now creating a copy of arrays. You would be thinking why this topic is here. We can always create a copy like old array equals to new array or something like that. We can just do that and it should create a copy. However, there is a small difference in Python. In NumPy and pandas, this thing is very common. That is, whenever I'm running this statement like new array equals to old array, if I run this, then the new array will not create a copy of this array. It will only create a pointer to the original value or the pointer towards its original value address. Now to see that whether it is true or not, let's see the example. Now I have just let's assume that this creates a copy of the array. I have created a copy of array and it should have the same value as old arrays, that is 0 to 10, 0 to 9, and I am trying to change the 0th value, 0th element of the new array to 20. If it would have been a copy of the original array, it should not affect the original array. But here is a small change. It is a pointer. Oh, sorry, I forgot to run that one, and let's skip this one. Now you can see value is changed in both arrays, in new array as well as in the old array. So it is true, it is just creating a pointer to the original array. Now how will you create the copy of the array? Simply use a copy function, that is new array equals to old array dot copy. Remember to use that whenever you are working with NumPy and pandas. It is a very useful thing to do, because sometimes we end up changing the values of our main arrays, and which cause problems at the end of the computation. Now you can see whenever we change the value to 20, so it affected only our new array value, not the old array values. Everything is constant, so it created a proper copy. So that covers our part for the copy. Just remember to use the dot copy function whenever you are trying to copy the values. Now coming to our next topic, reshaping arrays. What do you mean by reshaping? You would be thinking that, like, if I have given a straight array like 1 to 5 values, or let's say 1 to 6, it is a 6-digit array. So if I want to break it into like 2 by 3 array, 2 rows each having 3 columns, then total elements is 6 only. So how can we achieve that? For that we use the reshape function. Now coming to our example, first of all I am creating an array of size 9, and here is the array containing value from 0 to 8. Now reshaping it into a 3 by 3 array. For that I am using a function called reshape. Like, this is a new variable and I am putting its value to reshape 3 by 3. The first element, or the first item value that you can say, represents the row, and second one represents the column. So just keep that in mind. And here is our array, a 3 by 3 array, which is obtained from this array. Just one thing to note over here, try to remember the cardinality of the arrays. You cannot convert a 9 element array into a 5 by 4 or something like that, because it can only be converted into an equal size array, that is the number of elements in the second array that we get after reshaping should be same. Similarly, the size of array is 9, and here also the size of array is 9. Now coming to our next example, where I am trying to create a 3 by 2 array. Ideally it should have created a single array having 6 elements. Then I converted it into a 3 by 2 array, that is 3 rows and 2 columns. Just like I said, 3 rows, 2 columns. Now let's try to convert this 3 by 2 array into a 2 by 3 array. Yes, we can apply the reshape function on 2-dimensional arrays as well. And here it is. I converted this array into this one. What I did is like similar procedure, 2 rows, 3 columns, and still the size of the array is constant, that is 6 elements. If you want to convert a multiple row array or a 2-dimensional array into a single row array, then you can do this. You can provide the reshape, the number of rows as 1 and the total values in it like 6, and we get this one, that is 1 row and 6 elements. That covers our part for the reshaping. Now so let's jump on to our topic, concatenating arrays. What do I mean by concatenation? For example, if I would have been given this array or 2 arrays having the same values, and if I want to join those arrays like 0, 1, 2, 3, 4, 5, then again it should have the value 0, 1, 2, 3, 4, 5. That's what I mean by concatenation, joining 2 arrays. And there are 3 functions that we can use for that, and they are concatenate, vstack, and hstack. I will come to these two a little bit later on. Let's first study about the concatenate function. With our example, let's see what happens over here. The first array x is 0, 1, 2, 3, and our next array is 4, 5, 6, 7. And if I want to join this array back to back, I just use the function concatenate x comma y. Just remember one thing, put the arrays in a square bracket that you want to join, and this provides me a new array having all the 8 elements into a single array. And one more interesting thing over here is like I can join multiple arrays at the same time, more than 2 arrays. And if I want to add the third array z together, then the statement becomes concatenate x comma y comma z, all three in square bracket. Let's run this one. The value of z were 8, 9, 10, 11, and here is the result that we wanted. However, one more thing that you need to note over here is like just like the reshape function, cardinality is very important, and like you cannot concatenate two arrays of different shape or size. What I mean by that, suppose this is a 1D array, I cannot join or concatenate a 2D array into this 1D array. If I want to do that, I can do the things like row wise and column wise, but again for them both the arrays should have the same shape, at least not completely same. If I want to join two rows together, the another array should have two rows, it may have n number of columns, no effect for that. And let's come to our new functions, that is vstack and hstack. As the name suggests, they will stack our arrays or concatenate our arrays vertically and horizontally respectively. Now what I mean by that, let's see that with the examples. Suppose first array is 1 comma 2 and our second array is 4, 5 and 6, 7. That is 2 rows, 2 columns. It also has 2 columns but only a single row. Now I want this 1 comma 2 to vertically join the second array, like it should be 1, 4, 6 in a single line and 2, 5, 7 in a single line. So what I can do over here is like use the vstack function which will join these two arrays vertically and same format x comma y in square brackets. So it provides me the new array 1, 2, 4, 5, 6, 7 together. And let's move on to the next function, that is hstack. It will join the arrays horizontally as just like vstack 1 comma 2, 4, 5, 6, 7. I want this array as it is after this one, so I use hstack function square brackets x comma y, and this provides me a new array 1, 4, 5, 2, 6, 7. So guys, that covers our next part, that is concatenation of arrays. Coming to the last topic, split arrays. What do we mean by splitting arrays? By splitting arrays, I mean dividing the main array into multiple parts or into small chunks. So for that, the function is split, vsplit and split. Let's start using with the split function. If I want to split the array at position 4, let's suppose this array, I want to split it to at position 4. Let's see what happens over here. It created a new array at position this one, and the values are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the function used for that is split x comma, and I just provide the position value that at which I want to break it. Now let's try to break our array into 3 different locations, providing me 4 different arrays. So this is the result for that. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now coming at vertical split, for that let's first of all create a 2D array, and this is a 2D array, and if I want to split this one at third row, by third row I mean this one, so it should be split into 2 parts from over here, and this should be one part and this should be the next part. For that I am put in the position 2. Let's run this one and we get the desired result. All we have done over here is just change the function name, and the procedure of applying it is same as split one. And we can also do this in the horizontal split, like breaking this array into horizontally at the fourth column. Like at fourth column I mean this one, the last one, and these three together. So the value over here will be 3 and it broke into two parts. So guys, that covers our this article containing all the basics of our NumPy array, and hope you liked it. In our next article, I will be covering universal functions or few mathematical functions that we can apply in NumPy. So stay tuned for that and keep learning. Hope you liked it. Do press the subscribe button and do comment whatever you like, and just do let me know what else you want to study from me. So thank you guys. Have a nice day.